Then for the pressure pipe networks, the bulk water overview. So I did get a lot of requests on this one, so I'm going to put more emphasis on this. So how we actually design a bulk water is the following. Yet again, you can either manually create the pipes and the structures inside of the network in Civil 3D, or you can use the automated pipe networks using Devotech iDas, which I am going to show. So the Devotech iDas has established yet again all of the catalogs for the pipes and structures in compliance to South African status, especially for water reticulation, as well as bulk water pipes. And then the network design and analysis can be carried out within Civil 3D without exporting everything. Thank you. That's so awesome. Then we can actually go take it a step further. We can actually do a system curve calculation, which I can then define if my entire network needs a pump. And then I can actually add a pump and boost the water pressure between reservoir structures. Now, it also includes, I can add air valves, scour valves, pressure reducing valves, non-return valves, fire hydrants, house connections, and many more structures that may be added to my water network. We'll have a look into that shortly. As well as the pressure analysis can be done inside of the Water Manager wizard, and reports can be extracted, views, and quantities can be saved to any Microsoft format. The design data will be expressed in the profile bands. Basically, you will see there's hydraulics, fittings, classification, slopes, and pipe inverts levels. Then finally, the piece of the resistance. There are various import and export options available to share the design of the software packages using Devotech iDas, which includes basically EPANET, CSV, Civil Designer, Technocat, and Genome. So you can actually go and export all of that artwork you've done inside of Civil 3D and Devotech iDas. So a more practical approach. So I am going to go a bit more in depth with this because there's a lot of demand for it. So just to start off, I've actually got an existing surface and I've indicated where my reservoir is going to start and where I want a tank. So I want to design a bulk water system for reservoir to tank. You could actually do it from reservoir to reservoir. You could do it reservoir to borehole to reservoir, and so on and so forth. So I'm just going to make it clarity a little bit better, and I'm going to switch off that surface. So the main steps that we normally have to do before we start is you need to have the right templates. So let me just elaborate a little bit on the templates again. If I go to my settings under water and I go to pipes, and inside of pipes, basically we have yet again all of our South African water pipe system standards in here. So as you can see, there are multiple pipes already created to our South African standard. So it saves you a lot of time and hassles. The same for the structures. There are the access manuals, air valves, panes, boreholes, existing water connections if you want to, double house connection, end cap, expansion, fire hoses, fire hydrants, as well as horizontal and vertical panes. We've got pumps, we've got reducers, we've got reservoirs, we've got saddles, we've got single house connections, we've got tanks. We basically got vertical panes and even water hammering illuminators. Very nice. So the actual steps is to actually go draw out this as a polyline because that's how we can automate our designs to change them into structures and pipes. So I'm just going to set up a nice thick little line. And what you need to do is simply manually go and draw out how you want your pipe network. Now, if somebody provides you with a polyline, you could also bring that in and generate your pipe networks from there. So you literally sketch out how you want your bulk water pipelines to be actually added, as you can see. So let me just make this bend a little bit easier, and the tank is going to be somewhere over here. So as soon as I do that, it actually finished drawing out the entire polyline. So now I need to go to my Devotech iDas command where the actual water is, and I can go to the bulk water wizard. There's a specific wizard. So you give it the name and you specify what parts list as well as what type of pipe you want and what type of structures and the final surface you need. Then I can simply say next. And then you can go define the alignment styles as well as your long sections and what type of profile views you want. Now they can also go specify the minimum pipe cover as well as divide the pipes at intervals. So you will pick up and divide them accordingly, as well as to specify the pipe profile reading. So as soon as I do that, it's going to ask me to select the polyline. So I select the polyline, and then I select the position where to place this long section. So in a nutshell, he does all of the hard work for you. And Bob's your uncle. There you go. You've got already your long section. So As you can see, it swaps out that polyline to actual structures and pipes. And if I zoom to my profile view, you can see it adds all of these pipe networks into them. Now, you're not limited to what just in here. You can actually go and modify them even better. So just for clarity purposes, let me just select my profile view and let's change some of these settings. I just want to switch off the major horizontal, vertical, and switch on the geometry points. There we go. So it looks a little bit cleaner, so everybody can see much easier. So what you still can do is, inside of this entire profile view, you can still go add structures, you can swap structures, and so on and so forth. Like say, for example, some of them are very steep or very deep. So what I can do is I can actually go and say insert a structure. Let's say, for example, I want to add another structure. If I select insert structure, I can go and specify for what network it is and what type of structure I want to add. So you can add, let's say, for example, any type. Let's go and let's say, for example, we want to add a pane. It also allows you to specify the depth below NGL in meters for the pipe. So it's going to ask you to select the profile view first. So you select the profile view, then you select the pipe and where you want to insert that structure, and boom, it adds one. Already at a 1 meter depth from NGL. So you can actually go with the same command, do it previously on other pipes. As you can see, we can add multiple. So this is very nice. You can do this for the entire network all the way till the end. So you can actually go define those levels. Now, some other elements you can also go and have a look at is, for example, if you want to move a structure. Now, sometimes moving a structure in a profile view is very tedious in Civil 3D, but with Devotech iDas, we've got this nice little move structure command that says select the structure, and then we'll move it in the profile view only. So it's still on the same geometry of the alignment, but you can actually go and move it out. So as you can see. So this is a very nice specific technique because sometimes moving these elements are a bit tricky just using normal Civil 3D on its own. So yet again, you just select the structure, and then specify the new position, and then you will actually go and update where you want to place that. So the other element that we need to start discussing is, okay, we've started now with junctions. What about the rest of the structures? I want maybe, for example, more elements inside of my system. So you can also use the grade pipes, for example, command. I also want to just showcase that. If I select the one structure in between another structure, let's say this lower point, we have this grade command that actually can grade multiple pipes simultaneously. So it's going to ask you, do you want to apply a drop as well as specify the pipe matching inverts or ground or senders? You can actually do that. As well as they need to provide a value drop between the structures. Now, I don't want that. But if I want a specific slope, let's say 1 in 30, you can see it regrades that entire pipe network at once. So the one thing you need to do just to make sure is on the other side, I'm just going to do this is much easier just to move out that point to make it connect. But basically, you can still use either combination of the grade pipes to move these elements or regrade pipes systems inside of Devotech iDas. So it saves you a lot of time when doing these designs in profile. Then if I want to swap out any structures, I can go into say swap structure. This needs to be a reservoir. So I go to the tools and select the structure I want, and I'm looking for the reservoir. So as soon as I select the reservoir, I can actually select it and it will swap it out to the actual reservoir itself. So there we go. It's actually now an existing reservoir, and I can still do this now for the air valves, the scour valves, and for my tank. So basically, if I zoom in to the end of my system, I need to go swap this thing out to a tank because we're going to illustrate the tank itself, where I can go define and select the tank. So let's just go downwards a little bit. I'm looking for tank. There we go. Tank, and I can select this structure, and there's the tank. So as soon as I do that, it adds the tank to it. Now, yet again, like I mentioned, you can still go swap out these things for the air valves, as well as you can even add elements. So let's say, for example, you want to swap a structure in the profile view. You can also do that. So for example, if I want to say, for example, I'm looking for an air valve, the air valve, I can go select, and then literally you can select multiple structures. That's the beauty about this Devotech iDas command. You're not limited to just one. Normal Civil 3D, you literally had to go select one by one and then swap them out. And that took forever. Now with this Devotech iDas tool, you swap out multiple structures at the same time. In long section, and in plan view. Then for the scour valves, let's just add a few scour valves so you guys can just get a feel of what type of elements we've got inside of our templates. If I go to the scour valves, I can go and specify exactly where my low points are. I'm going to actually put that one as a pump later on. So let me just select one of these ones and select another low point somewhere over here. Just for illustration purposes, I'm not going to do too much depth design for this. But basically, if you just simply select all of those elements and press enter, you actually go and add them to your system. So you can swap them out with ease, especially you can still go add more structures if you want different types to add them inside of your long section or in plan view. So sometimes you just need to run an auto map to make sure all of the data is corresponding in my long section again. And there's also some very nice tools that you can actually do. If I go to my profile, there's something called profile from pipes. And let's say, for example, I select the bulk water. It will actually create profiles already for specific elements. So for example, if you want a profile for your outside top, ground, center, invert, outside, bottom, or range, you actually have the capability to do that. So as soon as I do that, I select OK, because I want to compare if my NGL and my top of my pipe is actually in a specific 1 meter increment. So if I know if I've got deep excavation or shallow excavation, that needs to be taken into consideration. So for example, if I go switch on my line, what you see, it actually does add that profile. And now the beauty about this is inside of Devotech iDas, I can simply go back to my profiles tools, and there's a nice little function that says compare profiles. Now what it does is ask me for the intervals. You can specify how accurate you want these things at per interval, and it's asking you to select the profile view, and I can select the profile view. As soon as I do that, it's going to ask me the following questions. It's going to ask me for the NGL surface as well as that profile view to actually start generating. So you can see you can specify profile 1 and profile 2, and then you can specify your minimum difference and your maximum difference. So it will indicate with you with a nice reddish color if your elements are in certain specs. So you can compare if your bulk network is deep excavated needed or shallow, and you can use this as a check. So it saves you a lot of time when recreating these elements. Then you can already, before running the analysis, have this requirement checked out. You can also export these data to CSV files for clarity purposes and reference for later use. So after you've added all of the structures, you can actually go swap elements out. You can still add pumps, air valves, and all of those things. So I'm going to just jump a step because I'm just cleaning this up. You can add labels to these things, and I just made it much more prettier. So I've added now annotations as well as I add data for the pipes, but I want to move on to the next step for the actual analysis part. So what I want to do is I want to actually add an actual pump to the system, but first I need to know what's my system curve, because currently I don't know if this water is actually going to go reach to the tank at the end of the day. So I need to swap out the structure just to as a junk or at any junction type it can actually be used. Then what I want to do is I need to go set up some settings inside of my Devotech iDas that will actually give me the system curve. So as you can see, this is where the location of the pump is. Actually, it's just a normal structure. It's not the pump itself, but that's exactly what I'm looking for. I just need to check for this specific pipe name, what type of pipe this is, because this is very critical when it comes to our designs. So what I can do is, after you've now cleaned up all of these models, I just need to make 100% sure about that pipe naming. So if I look for my structure quickly, there it is. It's actually P6, and I'm going to rename it because this is a very critical element in my analysis. So I'm going to give it a proper naming. I'm going to call this pump out, and there we go. So this is very critical because I need to go specify these elements inside of my manager. So after that, I can simply go to my Devotech iDas command, and inside of my water, I can go to, you could either, like I mentioned, we use the bulk water wizard or the water manager. If I select the water manager, it actually will open up the analysis part. Now, how does it look like inside of Devotech iDas? Yet again, it looks very similar to storm water. It also has structures and has its pipes. So you can see all of the pipes are there, and I need to go specify the roughness coefficient. Depends on which analysis type you're using. We're going to use Darcy Vespa. Then we can specify the roughness coefficient for, according to that standard, to be 0,015 roughness coefficient for my pipes. So that's the first step you need to do. Then for the structures, you can see it picks up the reservoir. And inside of my reservoir, I can specify my pressure head at that reservoir. Let's say, for example, 5. As well as if I've got a tank, you can actually do a tank sizing already. So you can specify your minimum level, your maximum level, the diameter of your actual pipe that's going into the tank. And we normally put this to 1000 because I don't want my tank to actually run out at the end. So what you can actually simply do is, if you go to the design data, you need to specify whatever head loss formula you're doing, as well as the end analysis, how long you want to run the analysis. So I don't know if the actual amount of water is going to reach my tank. So let's quickly do that. If I run a quick analysis, that's basically how easy it is. You specify the pressure heads, and then we go to the pipe conduits. And there I can see I've got a flow, which is a negative value. I've also got a velocity, which is an exclamation mark. So what basically does that mean? It basically means there's no water going to my tank. It's not sufficient enough to go into my tank anymore. So what can I do? This is in a case where I need to start thinking rationally. Maybe I do need a pump. Now, how do you define a pump? Now, the way to get the system curve, so it gives you an idea how much you're going to need. So what I need to go specify is just the demand. This is an estimate. You can specify any type of demand you think that's required, and then we can actually go and add a certain pattern for it, because a pump system curves is normally in different segments. And then something I need to make sure is inside of the pipes, the pipe out, which we just marked, I need to close it, because the reason why I'm going to close this is because it's going to allow me to actually run an analysis, and it will tell me exactly what my system curve is. And that's what I need to compare to an actual pump, which I normally get from my manufacturers and so on. So what I need to do is I need to just close the pipe before the pump, or in this case, the junction, which we said is a pump. And then I need to go to specify a pattern. Now, the reason why we specify patterns, so we can get more accurate results. Let's say, for example, I want to know half of this demand. Let's say, for example, 0.5. And then I want an actual scenario. I want a pump that actually needs to give me values at 60 demand and then double it. So I have a nice little system curve. You can still add more elements to be more accurate. But to get the more accurate system curve, we need to set up this pattern and assign the pattern to this element. So as soon as I do that, I can specify the inflow pipe. I made sure the pipe is actually selected, and I need to just rerun the analysis. Now, the analysis I'm going to run as a two-step analysis and run the analysis itself. As soon as I do that and I go to my report, it indicates to me for the first run at pressures 30 liters per second, I've got this values. And then for the second run for 60, I've got this 98.91 pressure head. Then for the 120, I've got a 135.01 pressure head. So that's going to give me my actual system curves, but you can actually go to the graphs, and inside of the graphs, you can actually go select the pump junction box, and there is my system curve. So this gives me an indication of how my actual pump needs to be. So I can actually follow these elements directly, and then I can do a proper design for the pump. So there are several ways of doing this now. How do you go about adding the pump? Now, very simple. The first thing we need to go define is I need to take out all of those settings which I previously done. For example, the structures, I need to go and maybe take out the pressure. You can see the pressure has been added as well to this, but I need to go and take out all of that previous steps I've done. So for example, if I need to go and define the pump itself, I can simply go and take out the demand. So I set it to 0. Just cleaning this up pattern again. I need to go to that pipe, which I closed. I need to open it. Otherwise, the water will not flow for the next step. So if I say, okay, for now, I need to physically go swap out that structure as an actual pump, which actually has power. So I switch it out to an actual pump, and it actually updates accordingly. So now that's an actual pump structure. If I go back to my water manager, I'll just quickly open that up, and it will actually allow me now, if I go to the structures itself. So inside of my water manager, I can go to structures, and under my structures, let's make this bigger again. If I go to pumps, there's the actual pump. So inside of this pump, you need to specify the outgoing pipe as well as the curve. Now the curve you normally get from the manufacturers, so you know roughly what type of pump you're using. So what you can do is you can create your curves inside of Devotech iDas. To create a new one, you simply go and create them. So let me just delete the existing one, so just to show you. And let's go and create a new one. Let's call this, for example, pump curve and okay. Okay, just gonna have spaces. There we go. So what you can simply do is you specify this is a water pump curve. So it asks you for the flow and the head meters and decreasing. So you specify how many rows you want. So I'm going to just add 3. And let's say, for example, I get the manufacturing catalog pipe system on my hand, and it says it has a system curve for one of them for 40, 80 liters per second inflow, and the last one was 100. And I can go and specify the actual head. It provides me this pump at these certain increments as I go along. So you define actually the entire pump system curve inside of Devotech iDas to create a new pump curve. Now, after I've added that pump curve, I can simply say OK, and it's going to ask me to select the pump curve. You can either say pump curve or power. If you have got a specific to power, it also works. Then you don't need a curve anymore. Then finally, for the design criteria, we'll just make sure we run this analysis yet again for a 3-step analysis system. So it runs for those 3 cycles because I specified it in my curve. And if I go to my report, I can see exactly reservoir is emptying, tank 1 is filling at to 1 meter because I set that to be 1. And then I can go and have a look at the pressures inside of my report. So there's for the first step, the second one, and for the third, if I go down, it actually has that pressures. Then for the structures itself, in the nodes, I can actually see the pressures. So you can see it actually has the pressures already, as well as the pipes. The flow is now positive value. It basically means there's a sufficient amount of flow and the velocity meters per second is not having warning. I can also go view this in the view tab. If I want to see pressures or head or velocity, you can actually go define all of these elements in the nodes to switch on whatever you want. Let's say just the nodes. And there I can see the pressure I've got and where my pump actually is and where it pushes out to have sufficient amount of pressure to my tank. So you still have got all of those capabilities to view these elements, as well as I want to update these elements. And also, yet again, you've got quantities, so you can specify the quantities as well. Now, after all of this has been done, we've got the beauty about Devotech iDas. It basically does the hydrology and energy grade line again for you, as well as it defines your hydraulic data, as well as if you've got fittings, it tells you if you've got a straight fitting, 11.25 fitting, or whatever type of fittings you have. So actually modeling these things up, analyzing it, it's all much easier inside of Civil 3D and Devotech iDas. Okay. So it saves you a lot of time because, like I mentioned, all has still been done inside of Civil 3D. So, ladies and gentlemen, to the end, the final wall report and statistics of this entire scenario. So I'm going to do something that I've never done before. And this time, I'm going to let the audience have the opportunity to vote for which one do you think is the best and which one you prefer. So we will quickly run a poll, which is actually you guys deciding which one you would prefer to go to war with. And when I'm talking about war, I'm talking about your project, civil projects. So just give you a few seconds for the guys to give the answer. Okay. We'll just give a few more seconds for the guys and let's see the results. And ladies and gentlemen, it's a drum roll. 94% says Civil 3D and Devotech iDas has won the war. Thank you so much, ladies and gentlemen. This is a new type of approach for me, and I'm glad that we did it. I get really good feedback on this. So just the final Civil War reports. In the end, basically, we're all on the same team. Civil 3D and Devotech iDas versus our common enemy, which is basically civilization and environmental impacts. So, ladies and gentlemen, my final words for this series of the Civil Wars is that every engineer out there is a superhero. We have dedicated our time, our passion for finding better solutions to everyday demanding tasks, only to give our children and our country a better future. So, pat yourself on the back because you are a champion, ladies and gentlemen.